Right, so let's have a look at question 15 from the 2014 revised higher physics paper. It says an oscilloscope is connected to the output terminals of a signal generator. The trace displayed on the screen is shown below. And so we have this trace, and then it goes on and says that the time base of the oscilloscope is set at 30 milliseconds per division. I'm just going to scroll this up a little bit more so we can see the answers. The frequency of the output signal from the signal generator is given as, or is. So we need to determine the frequency by knowing the time base, and we can get information from the oscilloscope screen to determine the period of the wave. So let's do that first of all. So the period is the time taken for one complete wave, so maybe from there to there, and that is 1, 2, 3, 4 divisions. And the time base is 30 milliseconds per division. So that means that the period t is 4 times 30 milliseconds, and that's 4 times 3 is 12, so that's 120 milliseconds, or 120 times 10 to the minus 3 seconds. So that's the period there. For the frequency, well, the frequency is the inverse of the period, so that's f is 1 over t, and so if we plug that into our formula, 1 over 120 milliseconds, or 120 times 10 to the minus 3 seconds, gives us our frequency. And my calculator says that that is 8.3. It's not very clear 3. I like to do my 3's better than that if I can. Recurring, so 8.3 hertz is the answer, and that would be E. Means, well, E is the correct answer.